Hello there, this is Mr. Dunaway with your first example of a flipped lesson. Basically, these videos are just supposed to be down to business, giving you material that you need to know that you can do on your own, and then we do the hard work together in class. You'll also notice that I have to talk kind of fast because I'm limited to 10 minutes per video, and that's not much time when this material gets kind of complicated. So what you need to do now is begin filling in the blanks here. This is pretty much review for you, but we're using it, like I said, to learn how to use the flip videos. Main thing here, I just want to make sure you all do recall that the dot means multiplication, and then this is subtraction, division, and addition. You're taking notes, and you should write down the things that pop up here that are not on your paper. Or if I write it down, you probably should write it down as well. Keyword here, variable, and that is a symbol, usually a letter, that represents one or more quantities, values of a quantity that can change. The quantity that can change. Okay, let's go on down the page and go ahead and answer some of these questions here. And whoops, number 5. It says circle all the variables. You could probably do that on your own. If you're not sure, you're just circling the letters in each of these. So if you would put circles around the variables, just so you show me that you know what that is. And then let's talk about this vocabulary here, as it is a couple of important phrases for you. Algebraic expression. You hear that? That's implying that there are one or more variables in that algebra expression. If it's a numerical expression, well, that just means you have numbers with maybe some math operations there. So in the next question there, it says, write an n if it's a numerical expression, and then write an A if it's an algebraic expression. So as we scroll on down, that first one says 6x. Well, that's algebraic because there's a variable. This is also algebraic because there's a variable in the R. This one is numerical because there are no variables, but it does have addition in it. And this is algebraic because the K in there. Again, I'm talking kind of fast because I have to keep it under a time limit, but what you would do at home is you would pause this video, get the information down, and go back if you needed to. Let's go on to the table on number 7, where it says it has a math phrase on the left and a math operation they're asking you to fill in. Well, if you have the phrase more than a number, that means like if I said, you have 7, I have 2 more than you. I'm doing addition there. If I use the phrase less than, you have 12 and I have 6 less than you, you would subtract. Sum, that's a key word that you will come here a lot this year. Sum means to add, spelled S-U-M. That means addition. If the phrase fewer than a number is used, that means something is being subtracted. And then on number 8, it says circle the expression that you would use to find this phrase 18 more than a number. Well, if you have 18 more than something, you would be adding. So you would circle the second one there, 6 plus 8. None of the other ones represent that particular phrase. And then it says now write an algebraic expression for 18 more than a number. Well, you would need to put an addition sign right in there. It's kind of hard to see in my video, but that is a plus sign there, n plus 18. 18 more than some number n. There's your variable n. All right, problem 2 here. It says, what is an algebraic expression for the following phrase, 6 times the number n? All right, and then they kind of, they're actually going to get to that one at the bottom here. Let's just look at number 10, where they want you to add, write in the words add, subtract, multiply, or divide based on these phrases. If you have the phrase 8 less than a number, well, that tells you that you are subtracting something. If they use the phrase the product of a number, that means you multiply. Quotient means you divide. N times 12, that means you multiply. The sum of a number n and 59, that means add. And then this expression 6 times the number n is written this way. You can use the dot. I actually prefer this, just 6n. That's really the best one. I think it's the most simple, and that's really the answer to the got it question they asked you up at the front, or at the top there. All right, problem number 3. This one, the got it says, what is an algebraic expression for the following word phrase? 8 less than the product of a number x and 4? And they're going to walk you through this one here. So watch what happens. Number 12 says, write an algebraic expression for the product of a number x and 4. Okay, so that means it's multiplying 4 times x, just for x. And then it says, underline the correct phrase to complete the sentence. The phrase is 8 less than a certain number. Okay, and then they gave you two choices. All right, this is a key piece right here. Be very, very careful on this particular phrase, 8 less than a certain number. What that means is that 8 is being taken away. So you're subtracting 8. So the way that it's written is actually backwards from the way that it's written in words. So what I meant to say is the math expression is reversed of the order, and it has to be that way with subtraction. The order does matter. So you would subtract 8 with that particular phrasing. Then it's for 14 it says cross out the expressions that do not represent 8 less than the number of the product of a number x and 4. Well, this one has addition, so they crossed it out. That one doesn't have a 4, so they crossed it out. And this one is backwards. This one is actually here. This one is actually 4 less than a product of a number x and 8. So it's not that one either, the only remaining one. This is it right here. There's 8 less than is right there. 8 less than the product of 4 and some number. Right there for number 14. All right, let's go on to problem number 4 here. It says, what word phrase can you use to represent the expression? All right, this is kind of a different page here, but they're wanting you to take these expressions and match them up with these phrases right here. The first one says the blank of a number x and 8.1. Well, they're talking about this first one right here. So you need a word that means add, and that is sum. Okay, the sum of a number x and 1, that is what that says right there. So they're wanting you to fill in words that would make sense based on that. The next one says the blank of 10 and some number x and 9. All right, well in that one, it's the sum, think of it, the sum of 10 times a number x. So it's 10 times x. So it's the sum of 10 times x and 9. So that's kind of a strange one there, but that is the plus sign is right there from this phrase, sum. The quotient of a number n and 3, that's talking about this one. The quotient of a number n and 3. And then the last one, 1 less than, we're looking at this one right here, 1 less than the product of 5 and a number x. And that's what they're looking for there. So that was a little bit confusing. That's something you might want to go back and review later if you're not sure how those worked out. And then let's take a look at how you can have a problem and create an expression, a table and an expression that represents that in a table. This particular example says you have a segment, a polygon, a regular polygon. That means all the sides are equal. And you draw a segment from one vertex to the other vertices. And then the question says use a table and a pattern to represent how many triangles are represented when you do that. So this is 6 sides, and it has 4 triangles. So that's kind of what the pattern we're looking at here. And I have to do something here because I just realized part of this got chopped off. So I'm going to make it look really strange. I'm going to unlock this and slide this over into the picture. I'm going to erase this and try that over again. I'll just erase all that stuff. You should already have it down. That'll work. If we had a polygon of 4 sides, okay, if we had a polygon of 4 sides, that would be a square. So if we did that, it has to be regular. Now it means you're not overlapping lines. You would have 2 triangles, or 4 minus 2. If you had a 5-sided regular polygon, well, it's not going to be regular now, but I get the idea. And then if you drew those, let's pretend all the sides were equal, you'd have 1, 2, 3, or 5 minus 2. And as that pattern continues down, what we can see is that whatever the number of triangles are would represent, if you subtract 2, you would have the number of triangles. So if you subtract 2 from the sides, you would have the number of triangles in a polygon. So over here, again, apologize that it got partially chopped off. If you got 4 sides, it would be 2. All right, I'm going to stop the video there, and hopefully that's enough information to get us through what we need to do for today. And let me see your notes.